You are welcome to online lectures with From Eternity the Schoolboy. Today we are going to take a look at chemistry, and we have a question on the board. The question says, calculate the mass of magnesium required to react with 100 cm³ of 1 molar solution of hydrochloric acid in the equation above. The relative atomic mass of magnesium is 24. This is the equation: magnesium reacting with hydrochloric acid, 1 mole of magnesium reacting with 2 moles of hydrochloric acid to form 1 mole of magnesium chloride and a hydrogen gas solution. For us to solve this question, we need to be sure that the equation is balanced. Let's take a good look at the equation. Here we have magnesium 1. Here we have magnesium 1. So magnesium is balanced. Hydrogen 2 here. 2 here. Hydrogen is balanced. Chlorine 1, 2 here. Chlorine 2 here. So the equation is what? Balanced. Now, let us look at the question again. Calculate the mass of magnesium required to react with 100 cm³ of 1 molar solution of hydrochloric acid. Now, basically from this equation, it's clear that 1 mole of magnesium react with what? 2 moles of what? Hydrochloric acid. Agreed. Now, if 1 mole of magnesium react with 2 moles of hydrochloric acid, how many moles of magnesium will react with number of moles of hydrochloric acid we can obtain from this? That means we're going to use this volume and concentration and get the what? Number of moles. Remember that number of moles is equal to concentration times volume. This concentration is mole per dm³. This 1 molar solution is certain as saying 1 mole per dm³. 1 mole per dm³. So if that is the case, we'll now use this concentration and this volume to get the number of moles of hydrochloric acid. Now, but the volume is in cm³. We need to convert this to dm³. So you can cancel out this dm³. 1000 cm³ will give 1 dm³. Then that implies that 100 cm³ will give what dm³? We cross multiply to get this x. This will now give us what? 100 cm³ times 1 dm³ over what? 1000 cm³. cm³ will cancel cm³. 20 will cancel 20 here. We are left with 1 over 10 dm³, which is certain as saying 0.1 dm³. So 100 cm³ is actually equivalent to 0.1 dm³. If that is the case, let us now calculate the number of moles of hydrochloric acid. That means number of moles is equal to what? The concentration here is 1 mole per dm³ times what? This volume, which is 0.1 dm³. And this will give us what? dm³ will cancel dm³. We are left with what? 0.1 moles. So we are left with what? 0.1 moles. 0.1 mole. So what it implies is that converting this 100 cm³ of 1 molar solution of hydrochloric acid to moles, we have what? 0.1 moles of hydrochloric acid. Now, if we obtain this 0.1 mole, what is the number of moles of magnesium that will react with this 0.1 mole of hydrochloric acid? So we look for this x. We call it x. So we look for it. X is now equal to, we cross multiply. We now have 1 mole of magnesium times 0.1 moles of hydrochloric acid divided by 2 moles of hydrochloric acid. Moles will cancel moles. So we are left with 1 mole times 0.1, we have what? 0.1 mole over what? 2. So if we do decimal movement, we have 1 here. If we say 1 divided by 2, we have 0.5. So this 0.1 divided by 2 is actually what? 0.05 moles. So 0.05 moles of magnesium is required to react with 100 cm cube of 1 molar solution of hydrochloric acid. This amount is in moles. So we need to convert this amount from moles to mass. And for us to achieve that, there's a relationship between number of moles, reacting mass, and the molar mass. Number of moles, reacting mass, and molar mass. Number of moles is equal to reacting mass over molar mass. We have gotten the number of moles of magnesium to be what? 0.05 moles. We don't know the reacting mass, so we are looking for reacting mass R. Molar mass, from this quick question, molar mass of magnesium is 24 gram. Remember, molar mass is mass of 1 mole. So here now, because we are now looking for it in terms of mass of 1 mole, this will have this relative atomic mass will now become 24 gram per mole. 24 gram per mole. Mass of 1 mole of magnesium, 24 gram per mole. So if that is the case, we now look for what? R. So R is now, which is reacting mass, is now 0.05 moles. Sorry, let me come up so that we can see this clearly. Let me come up here. Let's find R. R is now equal to, we will cross multiply, 0.05 moles times 24 gram per mole. So mole will cancel mole. We are left with gram, which is the unit of mass. So R is now equal to what? 0.05 times 24 gram. This 0.05 is the same thing as saying, 0.1. We can move it back to what we got before, so we can easily cancel out 0.1 over what? 2, yes, times 24 gram. Yes, we can easily cancel out now. 2 divide 24, we have 12 gram. 12 gram times 0.1, we have a 1 shift decimal movement. So we now left with what? 1.2 gram. So actually, the mass of magnesium required to react with 100 cm cube of 1 molar solution of hydrochloric acid with respect to this equation is 1.2 gram. So the mass of magnesium required is 1.2 gram. Thank you very much for your attention. If you have any question, feel free to chat me on WhatsApp. My WhatsApp line is on the screen. Please subscribe to my YouTube channel and follow me on Facebook. My YouTube channel and my Facebook page name are the same thing. From Eternity, the Schoolboy, is on the screen. Please like my videos, share, comment. God bless you as you do so. See you next time.